Okay, let's get started here. Week 1, Einstein in context. I hope you've had a chance by now to view the introductory video clips, the video clip that gave you an overview of the course and how we're running the course, the 3 different approaches to the course that you can choose to pursue. Video clip on how to succeed in the course, or really how to succeed in any course. Hopefully some practical tips there and insights that can help you in the learning process, that construction process, almost like building a skyscraper as you build the foundations and then floor by floor and slot things in terms of your understanding. Rules of engagement for the course and what the course doesn't cover, some examples of that. If you wanted to, the math review can be good whether you've had a lot of math recently or not so much math recently, just to review a few of the things that you may see later on in the course. Again, if you choose a more qualitative approach to the course or the auditing approach to the course, you don't have to get into the math as much. Also a reminder, we'll be having handouts for each week to give you an outline of the material, the assignments, and so on and so forth, the quotes of the week, so you won't have to write those down. You'll have those there for you. But remember, one of the things we talked about in how to succeed in the course is note-taking is important. So I'm not going to give you everything on the handouts, but it'll be important for you to take notes as we go along. Just pretend like you're in a lecture hall or something like that, or in a seminar room, and not just watching a video, but for whatever reason, writing down things seems to engage our brains a little bit better than just passively watching. One of the quotes we actually gave in the How to Succeed in this course video clip, I also have on the week 1 quote. So we have three quotes for this week, and the first one is from previously, so you may remember it. I hope you remember it. Einstein said, "It is not the result of scientific research that ennobles humans and enriches their nature. Ennobles humans, enriches their nature, but the struggle to understand while performing creative and open-minded intellectual work." And certainly Einstein knew a lot about those struggles, because he struggled for years with some of his theories, reaching dead end after dead end, and always sort of turning around and trying another path until he was able to break through to the insights that, frankly, we celebrate him for. And so in a sense, we're following in his footsteps. He's blazed the path for us. We want to understand the results of his investigations and that path. And he says that has the capability to actually ennoble us and enrich our nature. So I hope you find some of that in this course. So that's one of the quotes for this week. Second quote for this week: "Science as something already in existence, already completed," say your textbook, "is the most objective, impersonal thing that we humans know. But science as something coming into being as a goal is just as subjectively, psychologically conditioned as are all other human endeavors." So the idea that there is this objective side to science. We are able to use our intellects to understand nature, which is really sort of a miracle in its sense. It's that there's this fit between our understanding and what nature actually seems to be like. So he's saying, when you reach that, the science maybe you read in textbooks or other places, that seems to be very objective. When you actually look at the process of science coming into being, it has all the human frailties and foibles and triumphs as any other human endeavor does. And so this week, I hope, especially in terms of Einstein in context, if you're able to read the profile of the young Einstein, you'll get some more insights into what he was like during this time in his life and in the larger context of what was going on besides his scientific work. And then third quote for this week: "When I examine myself," this is Einstein again, "when I examine myself and my methods of thought, I come close to the conclusion that the gift of imagination has meant more to me than my talent for absorbing absolute knowledge." So the gift of imagination. He certainly had a talent for absorbing absolute knowledge and insights into that sort of thing, but it was the gift of imagination. In fact, Einstein was famous for his thought experiments, and so it's not one of his thought experiments, but it's related to one of the key principles that he uses actually in the theory of relativity, and of course the principle of relativity, which actually goes all the way back to Galileo in the 1600s. So, thought experiment for this week as an assignment. Again, you can see it on your handout, but we'll read through it here. So, gift of imagination. So imagine that you wake up inside a room with no windows, one locked door. You checked it's locked, so you can't get out. You can't see outside. And look around, you see a table with a number of items on it. There's a desk lamp, which is plugged in and turned on, so that you actually have some light to see by. There's a tennis ball, a bunch of string, a pitcher of water and a cup, candle, box of matches, music player with headphones, a skateboard, and a wooden stool are also in the room. The music player has a sign on it saying, turn on for instructions, so you do, put the headphones on. And you're told that you're in a specially designed, vibration-proof and soundproof train car on a set of straight and level tracks. And your task is to use one or more of the items you find in the room to determine whether you are moving or not, whether the train car is actually moving on the tracks or whether it's just stationary. And there's a 30-minute time limit, so you don't have forever for this. You also can't, knock a hole in the wall or destroy the ceiling or anything like that to look outside. So it's just within the confines of the train car itself. So the challenge is to think of some creative ways to use the items that might indicate whether or not you are moving. Now I have to give you a spoiler alert here, so you don't spend hours and hours and hours on this, but I think it's still valuable to think about it. And that is, the principle of relativity says you can't do it. Okay? There's no way you can use those items in the room, or really any items that you might find there, to figure out whether you're moving or not. But just the process of thinking about how you might do that, and then coming up with a certain way, perhaps, that might work, and then thinking about, well, would that really work? Einstein, and actually Galileo before him, would say, no, it doesn't work. So try that as a thought experiment to engage the brain, get those mental juices flowing on that. So that's one of the experiments, really a thought experiment, to follow in the footsteps of Einstein a little bit there. And in the next video clip, then, we're actually going to look at physics and Einstein in context. Physics circa 1900, Einstein circa 1900, just to give you a sense of, what kind of scientific and technological world was Einstein born into in 1879, the year that he was born. And then as he grew up, went to university in the late 1890s, and then on to 1905. What was going on? What were some of the key things that had happened in previous generations in the 1800s that really formed the scientific and technological world that Einstein found himself in, and then actually influenced his thinking in several ways about the special theory of relativity.